Hi, Mr. Wright here, and welcome to this film in which I will work my way through 5 trigonometry IGCSE questions. Now, these are all questions from Edexcel higher papers, and they're slightly harder questions than in the previous film. So I reckon these are all about grades 6, 7, 8 kind of thing. They all involve trigonometry, always in 2 dimensions, but the problems are a little more complex. If you want to download the questions, then you can do the questions before me, and then you can watch the film and see how you have got on. Or, of course, you can work through the questions as you watch the film and work alongside me. So to download the questions, hit the link in the description, and you can download the IGCSE questions, which I'm about to start to do. Right. I hope you find the film useful. Tell me in the comments how you get on. Get in touch if you have any questions. Okay, let's make a start. Question 1. I've got an isosceles triangle here, ABC, and I'm told some information here which you need to read carefully, but it's all on the diagram. And the question is to work out the perimeter of this triangle ABC. So that's the perimeter of the triangle ABC, the perimeter of that triangle. So I need to work out the length of that red line and give my answer to 1 decimal place. Okay, here's the triangle here. And one of the lengths I need to find is this length here, the length from A to B. Now I can find that length by looking at this right angled triangle here, the top half of the isosceles triangle. That's 65, that's 16, and I'm trying to find that length, which I'm going to call X. Right, I can do that using trigonometry, of course. It is going to be sine, and I'm looking to find the hypotenuse X, so X will be the opposite divided by sine 65. So I can work that out on my calculator, and I get the answer 17.6540, and so on. Right, I'm going to rub that out now, because I also want to find this length here, because that will make up part of the perimeter as well. Now, how am I going to find that blue length? Well, the answer is that I'm going to look at exactly the same right angle triangle, the one which is the top half of the isosceles, and this time I'm going to find that length Y. So this time I'm looking to use tan, and I'm trying to find the adjacent Y, which will be the opposite divided by tan 65. Put that in my calculator, and I discover that the length is 7.4609. Okay, let's label the diagram here with the lengths I've found. So I've discovered that this length here is 7.46, this length here is 7.46, and the length of both of those sides, which I did in red, is 17.65 and 17.65. So the perimeter then of the triangle is going to be 2 times 7.4609 plus twice 17.6540. So I put that in my calculator, and I get the answer 25.114, and so on. And let's see, I'm being asked to give the answer to 1 decimal place. So the answer is 25.1 centimetres. And that is question 1 done. Question 2. All right, I've got a trapezium. I'm being asked to find the perimeter of the trapezium. Now let's have a look. So if it's the perimeter, well, I know that length already, and I know that length already. Now, I don't know this length, and I don't know the length of the base either. Okay, well, let's start with the length of the base. We've got to start somewhere. Now, I do know the length of the base up to this point. I know that the length of the base up to there is 21.2. But what I don't know is that length there. But I can see a right angled triangle. The right angled triangle is just at the end of the trapezium. It's this one here. There's the right angle. That's 43. Okay, this is my mystery length X. Now, do I know any other lengths of that right angled triangle? The answer is I do, because that's 16.7, and so is that. So that's 16.7 there. Okay, so how am I going to find x in that case? Well, I'm going to use tan, and I find in the adjacent. So x will be 16.7 divided by tan 43. Okay, so a bit of calculator action tells me that x is 17.908. So now I do know this whole length here, because it's going to be 21.2 plus the 17.908. Good. Right, let's delete that. Okay. Now let's come now to finding this length here. Well, that length there, that's just the hypotenuse of this top triangle. Look, y and y. So I could use the same triangle again. I can use the y and the 16.7 and the angle. So to find y there, I'm going to be using sine. I'm trying to find the hypotenuse. Y equals the opposite divided by sine 43. Again, bit of calculator use, and I can get the answer for y, 24.486. All right. Now I think I can find the perimeter of this trapezium, because I've got 16.7. Let's write that down. 16.7 plus 21.2 plus the length of that, well, that was y, wasn't it? 24.486 plus all the way along here, well, I split that into x, which is 17.908, and then the rest of it, which is 21.2. So all I need to do is to add up that lot on my calculator. That gives me 101.494, and I'm asked to give my answer to 3 significant figures. So my answer is 101 centimetres. And that is the answer for question 2. Question 3. All right, let's have a look. So we've got a semicircle with a triangle ABC inside it. Okay, A, B, and C are points on the semicircle. AB is the diameter, right? And then I've got some angles and some lengths, all of which are labelled on the diagram. Work out the perimeter of the semicircle. So I'm going to need to know that length plus that length. That's the perimeter of the semicircle. Now, let's see if we can work out the first of those first. Work out that red length there. That's the diameter of the semicircle as well, isn't it? Okay, what I'm looking at here is I'm looking at this length here, and I'm thinking, how can I work out that length? Let's have a look. It's part of that right-angled triangle, so let's draw the right-angled triangle up here. Not the best drawing in the world. That's the right angle there at C. That's A, that's B, that's 18, and this is the length I'm trying to find. Now, the length I'm trying to find is the hypotenuse there, isn't it? Okay, and I'm also given the 18 the adjacent. So I'm going to be using cos, and the hypotenuse x is going to be the adjacent 18 divided by cos 50. Okay, well, 18 divided by cos 50 gives me 28.003. So that is this length here, 28.003. Now, I also need to find, if I'm going to find the perimeter of the semicircle, I need to find this blue length here. Well, that blue length is half a circumference, isn't it? So the length of that arc is going to be, the circumference of a circle is pi d. So it's going to be pi d divided by 2. Now, what's the diameter of the circle? It's 28.003. So the arc is going to be pi times 28.003 over 2, whatever that is. So the whole of the perimeter of the circle is going to be the arc, which obviously I can work out on my calculator, plus this length here, 28.003. So that's the perimeter of the semicircle, which works out to be 71.99. Now it asks me for the answer correct to 2 significant figures. So the answer that I'm going to give is 72 centimetres for the perimeter of the semicircle. Question 4. The diagram shows a vertical cliff all right, with a vertical mast on top of the cliff and a buoy in the sea. All right, good. The height of the cliff is 100 meters, okay? And the buoy is at a point that's d meters from the base of the cliff. So there's the base of the cliff, and that's d meters away, the buoy in the middle of the sea. The angle of elevation from B to the top of the cliff is 20. Okay. Calculate the value of D. Right, what I've got here is I've got a right angle triangle. There's my right angle. Sorry, there's my right angle. Okay, and I've got the opposite and the adjacent here. I'm going to be using tan, and I'm being asked to find the adjacent because D is the adjacent. So the adjacent is the opposite divided by tan 20. All right, so on my calculator, that gives me an answer of 274.74 and so on. And I'm asked, look, to give the answer correct to 3 significant figures. So that's going to be 275. Okay, so the buoy is 275 meters away from the bottom of the cliff. And that's part A done. Right, part B. Okay. The point A, which is at the top of the radio mast, look, there it is vertically above the top of the cliff, okay? And the angle of elevation from B all the way up to A, let's just draw that. So it's the angle of elevation, so it's this angle. It's the angle from the horizontal there all the way up to A. So that angle there is 25. Can we find the height of the radio mast? Well, we've got another right angle triangle here, look. That's that distance D, isn't it? I know already that that's 274 point something. And I'm being asked to find the height of the radio mast. Well, I could probably find this whole length, looking at the right angle triangle, and then I suppose I could subtract away the 100. I'll be left with the height of the radio mast. Let's draw that out again here. So what I've got is I've got the C here, the buoy here at the point B. I've got the top of the radio mast here. And that angle is 25. Okay, and this is 274.74. Okay, so let's find the whole of this length here. The whole of that length, which I'll call X. Again, look, I'm going to use tan. Okay, and I'm trying to find the opposite. So X is going to be the tan of the angle multiplied by the adjacent. Okay, so that is 128.11. Right, so that's the distance from the sea all the way up the cliff and then up the radio mast. So that means the radio mast must be that height, 128.11, minus 100 for the cliff. So the radio mast is 28.11 meters high. And it asks me to give my answer correct to 3 significant figures. So the answer I would give is 28.1 meters. And that's question 4 done. Question 5. I've got a parallelogram here, and I'm given a couple of sides and an angle, all of which are labelled on the diagram, and I'm asked to work out the area of the parallelogram. Now, how do you work out the area of a parallelogram? Well, the answer is that the area of a parallelogram is the base times the height. Now, here's the base. Do I know the base? Yes, I do, because those two lengths are the same. So the base is 14.7. Okay, now what about the height? Let's have a look. Now the height is this length here. Do I know that height? I think I do, but it's part of a right angle triangle, look. It's part of the right angle triangle that goes from F down to hit that baseline, and then there's a right angle, then that's E, then that's the hypotenuse of the triangle. That's 9.3, isn't it? Do I know any angles? Do we know what this angle is in here? I think we do, because that's 90, and the whole thing's 106. So that top angle there must be 16. Now I can use trig. because I'm trying to find this length here, which is the height of the trapezium. So I see I can use cos. I've got to try and find the adjacent. So the x is going to be cos 16 times 9.3. Okay, put that in my calculator and I get a height of 8.9397. So now I can work out the area of that parallelogram because it's going to be the base, 14 times 7, multiplied by the height. Okay, when I do that on my calculator, I get 131.41 and so on. And then the question, I'm asked to give my answer, look at that, correct to 3 significant figures. So my answer is going to be 131 square centimetres for the area of my parallelogram. And that's part A. Okay, part B. Work out the length of the diagonal EG. Okay, right. So let's get rid of that for a moment. Got to work out the length of the diagonal EG. Let's draw that and have a look. There it is. Right. Now, I wonder if I couldn't do something here. And then here, look at that. Because then I could use Pythagoras, couldn't I? Okay, now I know the length from G down because I know that's 8.9397. That's the height of the trapezium, right? But this length along the bottom isn't 14.7. 14.7 only takes me as far as this. So I'm going to need to work out that missing little bit. But I can do that using that right-angled triangle at the end. Right, so what I've got is I've got a right-angled triangle at the end of that parallelogram. Kind of looks like this. This is 8.9397. This is the right angle. Do I know this angle here? Yes, I do. Okay, what is that angle there? It's going to be 16 again, because this whole thing's 90, and you can see that it's similar to that there. So that's 16, and I could work out that length there, couldn't I? Right, I'm going to use tan to do that. So TOA, I'm working out the opposite. X is going to be tan the angle times by the adjacent. Okay, so that gives me a little length there of 2.563. Okay, so that means the whole of the base, let's draw this big right angle triangle here. There it is, the whole of the base and the height. And here's the diagonal that I've been asked to find, right? I'll call that D for now, the diagonal. There's my right angle. This is the height, 8.9397. And this length here is 14.7 plus the little bit. So that gives me 17.263. So now all I need to use is Pythagoras here. I'm going to say that D squared equals 8.9397 squared plus 17.263 squared. I'm going to work that out and square root my answer. So it works out to be the square root of 377.94, which is, on my calculator, 19.44, and so on. And so to 3 significant figures, the answer I'm going to give is 9.4. And there you go. That is question 5 done. Okay, well done for making it through to the end of those questions. That's 5 relatively chunky IGCSE questions on trigonometry. I would say that those are about grade 6, 7, possibly 8. They kind of appear at the beginning of the second half of the Edexcel IGCSE papers. I hope you found the film useful. I hope you understand the maths. Do by all means leave me a question. If you're finding my films useful, subscribe to the channel. Why don't you? And then you'll receive notifications when new films come out. Do like the film, make me feel better about the channel, and give me some positive feedback. Thank you very much for watching. See you in the next film.